Yeah, please tell. Is the derivation of linear regression clear to you all, or you have any doubt in that? All right. So, like, if you have any doubt, then just okay. You can ask me anytime. No problem. For now, we'll be moving forward. All right. So let's see that there are some terms, okay, that we need to know. Like if, yeah, okay. So like we have a term which is known as convex functions. Okay, so
So will you share the screen?
oh, is it not shared? Okay, sorry. Yeah, yeah. Okay, okay, yeah. So there is a term which is known as convex functions. Okay, so what is the meaning of a convex function? Like okay, so suppose we have a function like this. Okay, now in convex function, if we take any 2 points, okay, and we join them, if we take any 2 points in that function and we join those points, okay, and if we find the value, okay, if we find the value, okay, on, okay, for any point which lies on this line, okay, if we find the y value, so this is the x and this is the y, okay, so if I take any point, okay, if I take any point on this line, okay, and if I see the value of y at this particular x, okay, so if I like move down, okay, and come to this point, okay, and then see what is the value of y, okay, at that particular x, okay, so that y value should always be okay, that y value should always be less than the y value of this. Okay, so it is basically like this. Suppose this point is x and y. Okay, now at the same x value, okay, so this will be my x over here, right? Okay, this will be my x. At this x, if we check the value of y on this curve, okay, so this will be x comma y dash. Okay, y dash will be this value, so this y dash should be less than y. Okay, always. Okay, or should be less than equal to y. Okay, so these kind of functions are known as convex functions. Now like if we take another function like this, okay, suppose the function is like this. All right, now let's take this, let's take this, these 2 points and then join the line. Okay, now we will take this point. Okay, so suppose this point is x and y. Okay, so at this point the value, okay, is y over here, and if we check over here, it will be x comma y dash. Okay, so which one will be greater over here, y or y dash? Which one will be greater, this y or this y dash will be greater?
Y dash will be greater.
Y dash is greater, na? So okay, so I'll say that this function is not convex. Okay, this function is not convex. So like why I'm telling you this thing, okay, because there is a, okay, we studied cost function last time. Okay, so can any one of you tell me what is a cost function? What is a cost function?
It is a function that measures the
Mm-hmm.
performance of the machine learning model.
Mm-hmm. Yeah, yeah, correct, correct. Okay, so okay, so the cost function should always be a convex function. Okay, and if it is okay, if it is a convex function, then what is the advantage that I'll get? If it is a convex function, then what is the advantage I'll get? Okay, I will come down. Okay, the advantage of a convex function is that I will get to global minima. Okay, if it is a convex function, then I will converge. Okay, then I will my gradient descent algorithm will converge to a global minima. Correct. So that is the advantage of convex functions. Okay. Uh, can you tell me what is cost function with respect to linear regression? What is cost function for linear regression? Which cost function are we using over there? Please tell, for linear regression, what is the cost function we are using? Okay, so the cost function for linear regression, what was that? Summation, okay, yi minus, okay, y predicted whole square. Okay, and like I was also dividing it by m is the total number of samples that I have. Okay, and I equal to 1 to m, I equal to 1 to m. Okay, so this is also known as the mean squared error. Okay, so this is the cost function that I'm using over here now. Okay, and what is the value of this y predicted? What is the value of y predicted?
mx plus c.
Mxi plus c. Okay,
Mxi.
for that particular okay, x I will be taking now. Okay, so this is so this function, okay, this function is a like convex function. Okay, this function is a convex function, like this is a equation of a parabola. Okay, so that's why I used this. I could have also used the matrix this also, no, yi minus yp. Why didn't I use this? This is also giving me the okay error that is coming, no? I could have also used the cost function this also, but why didn't I use this? Okay, so I told you the problems with this. Okay, I could have also used this, but I didn't use this. So can any one of you tell me what is the problem with this cost if I'll use this cost? If I'll use this cost, what is the problem? Why did I square the term? Why did I square it?
Derivation purpose for
Mm-hmm. Okay, one reason, yeah, one reason is derivation, and any other reason? I could also write like this, na? 1 upon m. I could have also written like this. Okay, so the problem is this, that why I'm squaring it and why I'm like here. What is the problem? Suppose yi is 0. Okay, and this prediction that came out, okay, that came out to be -1. Okay, so actual was y and I predicted -1. Okay, actual is 1, I predicted as 0. Okay, so if I will find yi minus y predicted, okay, what will be the value over here? Yi minus y predicted, yeah, what will be the value? Yi minus y predicted,
-1.
-1. 0 minus -1, what will it be? It will be +1, na? Okay, negative will get added. Now 1 minus 0, what will be this? Okay, so this will be 1.
1.
So like this is a straightforward. Okay, but if it is like this, then what will be it? 0 minus 1, it will be -1. Correct. Now what I'm doing, I'm finding the summation of all the errors. So what will be the error summation of all the errors? 2 minus 1, that is 1. Okay, so do you think that 1 is the total error that is there? what should I have done? Is 1 the total error that has occurred? The error is, see, error is 1, error is 1, error is 1. In reality, 1, 2, 3. In reality, the error is 3. Okay, but because if I'm taking only the difference, okay, then my error has reduced. It has become 1, but in reality, it is 3. Okay, so that's why I will not be taking the absolute difference. I will be taking the square of them. I could have also taken mod. Okay, I could have also taken the mod, like I'll take the mod of this. Okay, so what will mod return? Mod will return 1 1 1. Okay, but why didn't I took mod? Because there is problem with mod, because mod is not differentiable at 0. Okay, it's not differentiable at 0, so that's why we don't take this. Okay, so that's why we square the term. So like squaring the term has like two advantages. First, it will convert all the negative errors into positive. Okay, it will convert the negative errors into positive, and this function, okay, is differentiable, okay, over all the values. So that is the advantage of this. Okay, this function, we are easily able to find the derivative. Okay, so what is the derivative? Like this is the derivative, no? The tangent that we find. Okay, so we can find derivative at each point. Okay, and why do we find the derivative? Why do we find the derivative in the loss function? Please tell, why do we find the derivative? What is the use of derivative?
You find constant.
Huh?
Find constants.
Constants. Okay.
To
Okay.
find
Ha, ha, ha,
slope.
ha, 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 ha. So what will slope help me? How will slope help me? Yeah, you are correct. We want to find the constant using this, but how does slope helps me? Uh, okay, it helps me in getting the direction, in which direction I need to move. You know, if the slope is positive, okay, then I need to move in the left direction. If the slope is okay, if the slope is negative, then I need to move in the left direction. Okay, so slope basically helps me in okay, finding the direction. Okay, moving towards the direction of uh, okay, the minima that we have. Now if I don't use the convex function, what will be the problem? Okay, what will be the problem if I don't use uh, okay, so I told you this problem last time also. So what will happen, that this will come here, come here, come here. Okay, and here it will find the derivative. It will say that here also if I go, the cost has okay, cost has become high. Here also if I go, cost has become high. So now what will happen? It will converge over here. My algorithm will converge, but in reality the minima is over here. Okay, so that's why. Okay, so that's why I'll use convex functions. Okay, okay, convex functions for my okay, for my like for my cost, okay, for my calculation of cost. Okay, for my calculation of cost, or we can say the cost function should be a convex function. Okay, the cost function should be a convex function. Okay, so like this was the thing about the convex function. Okay, so just remember this, the convex function will have okay, one minima only. It will not have multiple minima, like you see now, that here we are having see multiple minima. Here also we have a minima. So okay, like this will be my global or local minima. What will be this?
Global minima.
This will be global minima. This will be global minima, and this will be local minima. Okay, so my goal is to reach the global minima. So that is the thing. Okay, now like if you would have now we'll see how will we apply gradient descent in okay, in linear regression. So like we have already seen how we apply linear regression in okay, sorry, like gradient descent in linear regression. This so we have already seen in the last session, but I wanted to tell you that we can do some optimization also. Okay, so like the cost that I wrote, the cost was this. The cost for, what was the cost for linear regression? Come on, I told you, like recently only I told
1 by
you.
n,
Uh-huh.
1 by n,
Mm-hmm. Summation.
summation of I equals to 1 to n,
Mm-hmm.
y actual minus y prediction whole square.
Mm-hmm. Okay, so y prediction is my mxi plus c. Okay, so this is the thing. Now what I need to do, that like let's see. Okay, let's try to write this equation, okay, in the form of matrices. Okay, because here I'm using the term all the time summation. No? I don't want to use the term summation. Okay, I want to convert this equation into a matrix form. Now let's see. Okay, so this is my y. Okay, the y is my matrix. Okay, so what will be the dimension of y? What will be the dimension of y?
One dimensional. That's actual.
One
But we
dimensional.
need to convert into two dimensional.
Ah, that's correct. That's correct. But that thing that we need to do programmatically, you know. But if we are talking about only the theory part, but with the dimension, if I think that y is a two dimension, then tell me what will be the dimension of y? Correct. M cross
3
1,
cross 1.
3 cross 1.
Yeah. Yeah.
Why 3 cross 1? Like, do you all agree with me now? See, the x, if x has three features in it, okay? If x has three features in it, okay? So then what will be the dimension of x? What will be the dimension of x? I have m data points. What will be the dimension of x? Come on, like how many rows are there? How many rows are there in x?
3 will be.
Three rows. Come on, like three columns we have na in x.
So M.
M rows.
Yeah, m rows and three columns. है ना? And for every row, I have only one y. Okay, one y value. So that's why I have m into, okay, so the dimension of y will be m into 1. Correct. Okay, now tell me what will be the dimension of m. What should be the dimension of m? Okay, so the dimension of m will be 3 into 1. Okay, why 3 into 1? Because we have three features over here. Okay, see, y is the dimension of okay, ms3. Okay, so if we have three features, what will be the value of y predicted? Like this equation I wrote for simple linear regression. Okay, and here we are considering a multiple linear regression equation. So tell me what will the equation of y predicted if we have three features? What will the value of y predicted? Okay,
mx1 plus mx,
yeah,
m1 x1 plus m2 x2
correct,
plus
correct.
m3 x3 plus
Yeah, exactly correct. M3 x3. Okay, so this is my x1, this is my x2, this is my x3. Okay, so this will be my, so like how many weights we need? For every feature I need one weight. Okay, for every feature I need one weight. And what will be the dimension of c? What will be the dimension of c? Okay, c will not be dependent on number of features. Okay, so that we can consider it as a scalar. Okay, this we can consider it as a scalar. So scalar will not have any dimension, it is just a number or a constant, we can say. correct? Now let's see, okay, that I want to find the, okay, all right, okay, okay, now what I want to do, okay, so now let's try to see this, okay, uh, this summation, okay, how will we do summation using the matrices only, okay. So will what we will do, y predicted will be m1 x1 m2 x2 m3 x3 plus c, okay. And let's try to write this using the matrices. So what will happen that okay, so okay, so can I write it like this, okay. Here what will I do, here I will have my this x1 x2 x3 and m1 m2 m3. Is this correct? Can I write this same thing as like this? Do you agree with me? Can I write like this? Okay, tell me what will be the multiplication of these two matrices? Like, what is the dimension of this matrix? M1, M2, M3. What is the dimension of this?
1 cross 3.
Hmm. And this one?
3 cross 1.
Hmm. Okay. Now tell me, if you will multiply, what will be the output? If you multiply these two
1
matrices.
plus m2 x2 plus m.
So it will be like this if you like understand the matrix multiplication. So then you can easily understand what we do in matrix multiplication. We'll take this term, multiply with this term, plus column, second row, multiply it, third column, third row, multiply it, and add all the sum. Okay, so so that is the way we write. All right. uh, Now what happens that I need to do this thing for all of, for I is equal to 1 to m. Okay, I need to do this for I equal to 1 to m. Let me write this cost function again. Okay, so the cost is 1 upon m summation I equal to 1 to m y I minus uh, okay, m xi plus c. Okay. Okay, let me make it little bit more complicated. Okay, m1 x1 plus m2 x2 plus m3 x3 plus c. Okay, so let me take the summation side inside. Okay, y equal to 1 to m yi, okay, minus summation of this term, summation of m1 x1 plus m2 x2 plus m3 x3 plus c. Okay, summation I equal to 1 to m. Okay, I took the summation inside. Now what will I do? The dimension of this yi is m into 1. Okay, so what should be the dimension of this expression? What should be the dimension of this expression? If the dimension of yi is m into 1, what should be the dimension of this? Okay, so this one should also be m into 1. Okay, then only we can add or subtract them. All right, so what will I do? Okay, we'll write like this. We'll write w transpose, okay, into uh, x transpose. Okay, W transpose into X transpose. See why I written it like this. Okay. This expression I have written it like this, or okay. So let's try to see that like why I have written the equation like this. So like what I did that okay, my original data, okay, my original data is in this form: x1, x2, x3. Okay, then it will be another row, that will be third row. Okay, so okay, so that's why I will write this equation like this, and this I will write like this. Okay, so actually like this is getting little bit confusing. Okay, let me show you in the code part, then it will make more sense. Okay, so okay, so this was like without the matrix operation. Yeah, here we were using the matrix operation. Okay, so here though it was a simple okay, this was simple linear regression, so here we don't need to worry. But here like uh, we need to see that how it is working. Okay, so the number of features is 3 over here, and okay, so this is my x. Okay, and this is my y. So let's see the shape. Okay, so the shape of x is this. Okay, and if I write like this, w transpose into x. So let me show you the value of, okay, one second, I'll run all of them. Just wait. I'll run all okay, so let's see the, it's not showing the weight. One second, I'll run from here. Just one second, I'll run in this part. Okay, so let me show you the input. Okay. Input is, okay, so it is x. Okay, so this is my x. We have 3 features. Okay, and I have taken the first 4 rows out of my x, and let me check the shape of x. Shape of x is 10 cross 3, and let's see what is the value of weight. Okay, so weight is this, and the shape of weight will be 3 cross 1. Now now if I write like this, weight transpose, okay, into x. Okay, so like this is my output. Here what has happened, that the weights, okay, 0 0 0, okay, 0 0 0, like first 0 was multiplied with this, second 0 was multiplied with this, and third 0 was multiplied with this. Okay, so 10 cross 3 weight transpose into x. Just wait one second, like this is not making sense how we are able to multiply them. Weight transpose, okay, just give me one second. I'll try to think that what is happening over here. One second, let's see the shape of this. Okay, so like what will this transpose do? Transpose will okay, convert these columns into rows, and if we check the shape of this, so it will be 3 cross 1. Now I'm multiplying this with my x. So but how it is doing this? Because the dimension of x is 10 cross 3, and dimension of this weight is 3 cross 1. So the number of columns should be equal to the number of rows. So like just try to just ignore this part for right now. Okay, let's see that in every iteration what we are doing. Okay, we are like multiplying these x into weights, okay, plus bias. Okay, so this will be my y predicted. All right, and I have okay, I have subtracted this y predicted minus y, and I have taken the square of it and like divided it by n. So this I have done. Then I have found the dw. All right, so this thing I guess I have already told you. Okay, so we have taken the dot product. Now the thing is that this x, okay, what is the dimension of this x? So x will have dimension m cross 3, okay, and the dimension of weight is 3 cross 1. Okay, okay, so basically it is like this only. Okay, so the dimension of x is m cross 3, dimension of weight is 3 cross 1. So when I will multiply them, so okay, so my dimension will become like if I do x into w,
M cross 1.
m cross 1, okay, x into w if I'll do. So okay, so that is what we have done over here. Okay, and we have added a bias, and I have done like this, and like I have applied the like the update equation that I told you. Okay, so everything is same over there, and like we have found okay this over here. Okay, now here you can see that what we are doing, we are updating this weight and bias separately. Okay, we are updating these in two separate equations, but there is a small trick that we can do in our data, okay, so that we don't need to write these two equations. Okay, okay, we'll store the bias value in the weights matrix only. Okay, so let's see like how we will do that. Just ignore this, like this okay, this part just ignore for right now, like this. Okay, here I got confused, so like this part is not correct. Okay, just ignore this part. Okay, this is not erasing. Okay, so okay, so the dimension of my x, okay, so the dimension of my x is m cross 3. We have three okay, three columns over here. Okay, and the dimension of w is 2 3, 3 cross 1. Okay, so x into w I'll do, so its dimension will be m cross 1. Okay, and to this I'm adding a bias. Okay, so this is what we are doing. Now what will I do? In this x I will add another column, okay, which will contain 1. Okay, this column will contain 1 only. Okay, and in this weight, the first entry, okay, the first entry I'll write bias over here. Okay, the first entry I'll write bias over here. Okay, so like what will be the dimension of this now? This x, what will be the dimension? Please tell what will be the dimension now if I add a column in front of it. m into 4,
Yeah, m plus 4.
m into 4. And for this weight, what will be my dimension? This will be 4 into 1. Okay, now what will happen, like I'll take an example, okay, then this thing will be more clear. Okay, okay, so this can be a little bit confusing, but no problem, like we'll do this. Okay, 2 1 3 5 1 8. Okay, and this is my x1, this is my x2, this is my x3, and I'll write my y. Okay, so y suppose is 8 1 3. Okay, so these are my x, these are my y. So this is my x, this is my y. So the dimension of this, I'm calling it as x. Okay, so dimension of x is 3 cross 3 and dimension y is 3 cross 1. Okay, now what I need to do in every iteration, like I'll have my weight, suppose it is 0.1, 0.1, 0.1. Okay, for simplicity I'm taking 0.1, and bias is 0.3. Okay, whatever we can take. Now when I will do x into w, okay, what will be my output? When I'll do x into w, what will be my output?
3.3,
Huh?
1.3, 2.3. Yeah, so sorry.
0.3, no? 0.3
Um,
plus 0.1 plus 0.2,
2.
you know? This row will be multiplied with this column. Same will happen for this one, 0.2 plus 0.1 plus 0.3. Here it will be 0.5 plus 0.1 plus 0.8. Correct? Correct, no? Now to this equation, I will add bias also, plus b. Correct? So what will be the value if we add the bias? Okay, if we add the bias, then what will happen? That 0.3 plus 0.1, 0.2, okay, plus bias. Correct? 0.2 plus 0.1 plus 0.3 plus bias. This bias will be added to every row. Correct? 0.5 plus 0.1, 0.8 plus bias. Like, is this step clear? Okay, if we add bias, then this will be added to every row. Now what will I do? I will like uh, take this b to the front. Okay, it will not create any problem. So it will be like this: 0.3 plus 0.1, 0.2, b plus 0.2, 0.1, 0.3, b plus 0.5, 0.1, 0.8. Okay, this I'll do. Now what will I do? That I will okay, I will write like this: 1 1 1. Okay, I'll rewrite this equation in another way. Okay, 3 1 2 2 1 3, 3 1 2 2 1 3, and 5 1 8. Okay, and here I'll write b. Okay, and what are my weights? 0.1 0.1 0.1 0.1 0.1 0.1. Okay, I will write this equation like this. So can I write like this? Is it correct? Like, are you all able to understand this step? How I did? Please tell, is this thing clear, or like it's not clear? Okay, so like there is no need to like put any extra, okay, mind in this. It's simply like every row and every column, if you will multiply, okay, if you will multiply every row with every column, then you will be getting this term. Okay, so what I have done over here, instead of writing this b separately, okay, uh, like this was my original data, this was my x earlier, no? Okay, and this was my weight, correct? So what I have done, I have written B, okay, in the topmost row in my weight matrix, okay, and I have added 1 in the first column, okay. So okay, so the dimension of this has become now 4 into 3 into 4, and this is 4 into 1, and the resultant will be this, okay. So what is the resultant? 3 into 1, okay. So now now I don't need to write plus bias separately, okay. Now I don't need to write plus bias separately. Now this bias has been included in this W only, okay. So my X predicted will become X into W, okay, and my Y, okay, Y to will be same. I'll not do any changes in that. Now I will apply like cost in this. So cost will be that only, Y minus X predicted whole square, okay. So like, will I use summation now? I guess we will use the summation also. Yeah, we'll use summation also, okay, because we'll be adding the all the individuals. But what I have done, now I'm only using the matrices, okay, and 1 upon m. So this I will write, okay. Now now I will what I need to do, I will just differentiate, okay, with respect to my W, okay, with respect to my W only. So okay, so this will be, okay, so I'll divide with respect to W only. So what will this become if I'll differentiate with respect to W? What is this? X into W? Sorry, this is Y. Okay, this is not X. This is Y predicted whole square summation. Okay, so this will be 2 Y minus X into W. Okay, and negative X. Okay, okay, so this will be the differentiation of this term. So now simply what I will do, I will just update my weights. So weight will be W minus alpha into del of cost by del W. Okay, so this will be my weight equation. Now I don't need to write the equation for bias, because bias has, okay, I have included that in my W only, correct? Okay, so that's why I'll show you that when I made this, okay, code using matrices only, then what I did, I made a like random matrix, okay, to this X, okay, I added 1 in the first column, okay, and that I did using this okay, this np dot append 1, okay. So once was like this was a like this m cross 1 matrix. So here m is 10, okay, so 10 into 1 size. So this was the matrix I created. Then I appended, okay, this ones to my X. So 1 came in the front, okay. So this one came in the first column. So this was the changes that I made. Also, okay, so you can see the weight that I initialized. Okay, earlier what I was doing, the weight that I was initializing, that was the its size was zeros, number of features. So number of features is 3, okay. But here I have taken number of features plus 1. Why I have taken number of features plus 1? The size of my weight. Why I have taken number of features plus 1?
We include that bias.
Yeah, for including the bias. Okay, so that's why I did this. So that is the thing. Okay, so now what I did, that y predicted, okay, I calculated x and weight, I multiplied them, I found the cost. Okay, so this is my cost, so this is like pretty straightforward. And for calculating the dw, okay, so I wrote like this. Okay, so just understand that why I have written this like x transpose I have written. Okay, why I have written this x transpose. Now what will happen, that the dimension of this will be like m into 1. Okay, if I'll find the resultant matrix, and the dimension of this is 3 into sorry what is this, m into 1, m into 3. Okay, so I will not write this at the end, I will write this in the starting. So 2 by m, okay, x transpose y minus x into w. Okay, so the dimension of this will be m into 3. Sorry, what will be the dimension of x transpose? It will be 3 into m, and the dimension of this will be m into 1. Okay, so the resultant will be, okay, the resultant that I will get will be of size, this resultant that I will get, it will be of size 3 into 1. Okay, and why this is 3 into 1? Okay, because I'm because the sorry, this will not be 3, this will not be 3, this will be 4 now, because I've added 1 to this. Okay, I have added 1, so this will be 4 into 1. Okay, so the weight is 4 into 1, and this term will also be 4 into 1. So that's why we will be, then only we will be able to do addition or subtraction in them. Okay, so the thing that I wanted to tell you is about the dimensions. Okay, how do, like, why did I wrote this transpose over here? Okay, so I guess you would have understood that why we have written transpose, because the dimension of okay, what should be the dimension of dw? What should be the dimension of dw? Yeah, please tell, what will be the dimension? How many entries are there in w? It is the dimension of w is 4 into 1, है ना? Because I have included, if I show you, see, the dimension of w is 4 into 1. Okay, because okay, I have added a bias also. Okay, so the dimension of dw should also be 4 into 1, because I will be adding this dw to my w, okay, during the updation phase. Okay, so so that's why this x new transpose. Okay, uh, so why I did this, like, I'll explain you again. Okay, why I'm like, have you understood this, why I did the transpose, or it's not clear? Please tell, like, is this clear, why I did the x transpose, like x transpose, and then I'm multiplying this x transpose with y predicted minus y.
Yes, sir.
Okay, 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 so like I ran this, and it converged like pretty quickly. Okay, in around 20-30 iterations only it converged. So if we will see the dimension of weight, because the number of features that I had, okay, the number of features were actually 3, you know, but the weights that I got are 4. So the first term here will be my bias. Okay, so this will be w1, this will be w2, this will be w3, and this will be my bias. All right, so like we can calculate this r square and all these terms. All right, so This is the thing. Also, one more thing I want to tell you, that it it may not be possible that my this cost function always comes to 0. Okay, just remember this. It may be possible that it cannot come to 0. Okay, so can you tell me when my this cost cannot be equal to 0? Okay, like if my points are like this. Okay, if my points are like this, so can you make any line which will make the errors 0? Is it possible? Can we draw any line which will make these errors 0? It's not possible, because my data is okay, like a randomly, okay, randomly distributed. Okay, but suppose my data is like this, so I can create a, then I will be able to find the straight line. Okay, so then only my cost will come to 0 in this case only, if the data is okay, it's actually linear. If the data is linear, then only this will happen. Okay, so just remember this thing. It is not necessary that the cost should always come to 0. Okay, the cost could be the cost could be like here also, like 20. The minimum cost could be 20 also. It is not possible that it will always come down to 0. All right, so like that is the thing. Okay, so like just understand this concept, okay, whatever we have studied, like, because this is very important. If you will, okay, study like deep learning and all those things also, there also same concepts will be used. So like, although we will not be covering deep learning in this course, but like if you will study like in depth this machine learning, then you need to study deep learning also, because like nowadays that is being used, okay, in everywhere, because the accuracy of those models is very high. Okay, so no problem. Like this is the code of linear regression, and like I have updated, like uploaded this code in my GitHub profile, so you can have a look at this code over there. Okay, now what will we do? We will study the derivation of logistic regression. Okay, so okay, so we will be studying the derivation of logistic regression. Now let's see, okay, how we do that. So in logistic regression, okay, what was my y predicted? What was my y predicted in logistic regression? Does anyone remembers? Okay, so my y predicted was like this: 1 upon 1 plus e to the power minus, okay,
Will you please share the screen?